So talking about how Linux actually works and how the boot process occurs in Linux, it is very important for us to understand that here, when we are talking about Linux boot process step by step, the very first the system powers on and the B BIOS BIOS, or we can say our UEFI that initializes the hardware, right? This is going to be the first step. BIOS has to load non-volatile memory and it has to run post, right? After this first step, it locates and loads the loader, and commonly we can say a grub, right? So this is going to be happen after that. So the third step is going to be that the bootloader loads the Linux kernel that we have, whatever the Linux kernel we have with us, into the memory, right? That is going to be comes into the memory using the grub that we have. And then the bootloader loads the Linux kernel into the memory, and the kernel then initializes the devices and mounts the root file system. This is how it happens or it begins. Then after that, the kernel starts the init process, that is a INIT process, right? The kernel initiated that particular process that is being there, right? So system services and daemons are launched at that moment, right? So these are the hidden processes that got started working at ever at its end, right? So the finally step that happens that the system reaches the login screen, right? You reached on the login screen and the user can start working in it, right? So discussing more and understanding it in better process, then it is there that the process begins the init program, which is the process started by the system after booting actually. So this init program is responsible for the first process to start in the system by the system after booting, right? So it initializes the system processes and services actually. So this is going to initialize this, right? So after that, when init performs its task, then what happens? Git GITTY is started by the init program to manage the terminal lines and display the login prompt. So login prompt is going to be visible at the yeah, GUI or maybe shell. It is up to the types of the operating system on which users are working, right? So it waits for the user to enter the credentials, and then the login program takes over it, right? And prompting for the username and password. So it verifies the user's credential for the authentication. And once the login is successful, the system starts the user default shell. So typically a bash shell is being used by many of the operating system. So finally, the shell provides a command prompt if it is there, allowing the user to interact with the system and execute the command. So this is the way how it is being done, right? This is how it is being done till now. Now further what happens, the process starts when the shell reads the next command from the user. If the input is from the keyboard, a prompt is displayed and the shell then search for the command. It checks whether a particular command, whatever the command is being executed, command is a built-in command. So if yes, the shell executes it directly. If it is a built-in command, then built-in commands, then very easily it got executed. It will not take any time. But if it is not, then a new subprocess is created, like, and the parent shell waits while the kernel loads and executes the program in the subprocess. See, if something is going to be done which is a default command, then it executes directly. But if something is being created which is actually not which is actually a subprocess is need to be initiated, then that happens. So once the execution completes, the sub process terminates and the parent shell resumes. So if it is a script, the shell checks whether it has reached the end. Otherwise, it continues and reading the next command. It continuously reading the next command and it will manages the things, right? So this is how it is being done, and it the shell the boot process takes place, right? So this is the way how it is being decided and it is being done, and this is being done, right? So this is the init program. Then we're having a gitty, right? We have a gitty which is got initiated at the display. Then we have to log in it. Then we have the bash, right? So we have to log in. We have to pass. We have to give the username password, and then we enter into the shell, and then we will start working, right? So in the same way, we will then read the next command. If shell searches the command, then if it is a built-in, then that directly it got executed. No, then it will simply create first of all the sub process, and the parent shell waits, and then after compiled is it's got compiled, and it is if it is executable type, then simply the kernel loads the program and overlays it in the sub process. If it is not, then we have to end the script, and it is happening in this very way, right? So this is how it is being done. Now talking more about shell programming that we are having here, we are talking about shell programming, which is open source computer program and the most important part of the Linux operating system, Linux and Unix operating system. So shell scripting is a program to write a series of commands for the shell to execute it, right? It can combine lengthy and repetitive sequences of commands into a single and a simple script that can be stored, right, and executed anytime, which reduces the programming effort. And these shells programs can be stored, and whenever we want to utilize them and use them in any other program, we can simply reuse them also to make our system, all right, fine. So the advantages of shell, if we will say, these are lightweight and fast, powerful for the system administration, highly customizable, suitable for scripting and automation. And talking about its disadvantages, complex for beginners to learn CLI. CLI shells require memorizing commands. Syntax errors in scripts can cause failures, right? So these are the main things that we are having about the shell script. Now, talking further about the file system and other things that we are having. Now, let's think and understand what do we have in the file system that we are having when we are talking about the operating system, right? So talking about the file system, we have like to understand about the concept of inode and superblock, let's first of all try to understand it using a book. See, every book or a file has a card, right? So file means a book, and inode means a card in a central catalog, right? If in a central catalog or in a library, I have to identify or I have to search a particular book, first of all, I have to search that particular card which is containing that information of the book, that in which particular shelf that book is lying, right? And that a small or a brief description of that book is written in that card. So in the similar way, a book is a file actually, and that card is a inode, right? So so every book or a file we can say has a card inode in a central catalog, and the library itself has a master index, which is actually complete library is actually known as a super block to keep everything in order, right? So this is the main concept to understand a file, inode, superblock, inode table, and boot sector, right? So now further discussing and let's understand what is a boot sector. A boot sector, or we can say a blueprint reader, this is the very first piece of the code the system reads when it starts up. It's like initial instruction instruction that tells the computer how to read the rest of the file system. It helps locate the super block actually. We also need to identify where super block is, and for that super block we have a boot sector, right? Then after that we have a super block. So super block is actually a master index, right? Boot sector is a blueprint reader, super blocks is a master index that we have, and this is the most crucial piece of metadata for the entire file system. Think of it as the file system's brain. It contains vital statistics and a configuration such as the total number of blocks and inodes, counts of free blocks and inodes, right? And the structure like the inode table. Timestamp of the last mountain, right? Error flags if the file system was not cleanly unmounted, right? So this is how we can say. So what actually means mounted means storage device like a hard disk, USB, or a partition is connected and accessible to the operating system, like which will helps us to open the files, read a particular file, or write on any particular file, right? So that is what is meant by the mounted. So talking about unmounted means like the device is safely disconnected or not currently accessible. So that is a unmounted, and the operating system is no longer using it and no file operations can be performed on it. So mounted simply means what do we mean by mounted actually? Mounted means simply which is ready to use, and unmounted means which are safely it is being removed and not in use, right? Then what do you mean by redundancy in key? See, when we are talking about files, when we are talking about data, we also need to understand that what do we mean by redundancy, right? So redundancy or redundant means it is very important or vital, and the multiple copies of super block are often stored across the disk to guard against corruption, like so that the corruption or the file will not be duplicate, or these things should be controlled. So that is there, that multiple copies of super blocks are going to be can be stored across the disk to guard against the corruption of any particular file, right? So that is why return is the most important key that to be understand. Now inode table is actually the catalog of identities. This is a dedicated area on the disk that stores all the inodes. So each file and the directory on the system gets a unique inode number. Each and every file which is going to be stored on the disk will be having a unique inode number, which is its indexed into this the table, that what will be the index value, right? So it's like finding a book's entry in a library catalog by its unique ID. That is a simply inode table we have. Now, what do we know by the inodes? So talking about inodes, actually, in Unix based operating system context, the file's identity card, this is where the magic happens for individual files and the directories. Means an inode does not store the file's name and its actual content. Instead, it stores all the essential metadata actually, right? So let's understand the main component actually that we of the file system we have. Actually, when you're talking about the file system, we have a super block, we have a boot sector, we having a inode table, we having a block bitmap, and we having a data block. So all these elements work together to efficiently store and manage data on a storage device such as the hard disk. So very easily we can able to reach to our data blocks using this structure of the file system that we are having. So further talking about the super block is one of the most critical parts of the file system. It contains the essential metadata actually. Super block, that is we are having, it contains all the essential metadata about the entire file system, such as what is the total size of the file system, what are the number of the blocks, what are the number of inodes, what is the information about free and used space. So in simple terms, the super block acts like a summary or a header that helps the operating system understand how the file system is organized. So if the super block is corrupted, the file system may become inaccessible, right? So next we have the super sector, right? When we talk about the super sector or a super block, it refers to the physical location on the disk where the super block is stored. So it is typically located at a fixed position so that the operating system can easily locate it during the booting or a mounting process, right? So the super sector ensures that the system can quickly access the super block information, right? When moving on the inode table. So where we are having the inode table with us, this is another crucial component. An inode or inode or an index node is a data structure that stores metadata about a file, right? Such as its size, permissions, ownerships, and pointers to the actual data blocks. So each file in the system is associated with a unique inode. The inode table is essentially a collection of all these inodes, and it does not store the file name or actual data. It just plays a vital role in locating and managing the files that where the file is actually present, right? Now let's discuss the block bitmap. So right, so block bitmaps are the like is used to keep the track of each data blocks, whatever the various data blocks we have. So to understand and to trace them, that the data blocks which are free and which are occupied, it's typically to keep the track that which particular data block are free and which are occupied. So it is typically represented as a series of the bits we have, and the value of 0 may indicate the free block, and the value of 1 means it is the block is in use. So this mechanism helps the complete file system effect, efficiently allocate and deallocate the storage space that we are having. Right? So finally, we come to the data blocks that we are having here after studying it. These are the actual storage areas where the contents of the files are stored. Right? When a file is created, its data is written into these data blocks, and the inode contains pointers that link to these data blocks and allowing the system to do it, right? So this is way how it is being allowing the systems to do, and the inode contains the pointer. So inode, all inodes are containing the pointer actually that link to these data blocks, right? So these pointer are going to link to the data blocks that we're having and allowing the system to retrieve the file content when required. So we can say that the super blocks provides an overview of the file system, and the super sector stored its location that we are having, and the inode table manages the file metadata, and the block bitmap tracks storage usage, and the data blocks hold the actual data, right? So this is how it is being covering, right? So further, these are the few steps how we have to what we have to understand about the shell scripting and all, right? So shell scripting is for various type of small programming that we're having. We can do a small programming using it. So a shell executes it directly, or if not, new subprocess is created, right? That is all the things like what are the various commands, how we have to do this shell programming, how a new script file is can be created, how we have to add a particular command in a sh shell, right? And then how we have to execute. So we can create a file using VI editor, right? And then we have to save that particular file using the sh sh extension to show that this is a a shell script file. So we have to write the code, and then we have to save with that particular file with that particular extension. Then we have to simply execute it like it, like this is a simple file name that we have, and we have to execute it, right? The detailed description of the execution of these commands is already available in other YouTube videos of this channel. So again, what are the shell variables that stores in the form of characters and the numbers? And similarly, shell variables are used to store the information that can be the shell only, right? So various variables we are having, and various shells we have. So the details can be detailed video is also available in the YouTube channel. You may explore, right? So how to change the login shell? This is how we can change the login shell. First of all, we will able to see that where is the in which cell, what are the various types of the shells we have, in particular shell we are working currently, and if we want to work anything in the shell, or if we have to perform any task in the shells, it may ask you some password, and then only you will able to do the things, right? So all the Unix advanced Unix command you can watch through the other YouTube videos that are being already launched in our channel, right? So this is the way how we are how we can say, and we are discussing about the default login shell we have, and command line interpreter we have with us, right? So these are the things that we are talking about here. Fine. So what are the file system, what the shell scripting, how Linux works, what are the simple things that we have with us, right? So this is the way how we can able to understand it and talk that these are the things we are having and we have to understand.